7.2, the product rule. The product rule says that to multiply two exponents with the same base, you keep the base and add the powers. Remember, in any exponent, for example, 2 to the fourth, 2 is your base and 4 is your exponent. So in order for you to be able to use the product rule, your bases must be the same. So in the problem under arithmetic, it says 2 to the third times 2 to the fourth. So the base is the same, so we keep that. And then we add our exponents. So 3 plus 4. Okay, so we get 2 to the 7th power. Now, the reason this works the way that it does is because 2 to the third power means that we're taking 2 times 2 times 2. And 2 to the fourth power means we're taking 2 times 2 times 2 times 2. And if we multiply all those together, we've got 2 times itself 7 times. This works not only with a number base, but also with an algebraic base, meaning that you're using a variable. So here we've got x to the fourth times x to the sixth. And so we leave our base the same, and then we add our exponents. 4 plus 6, so we get x to the 10th. Okay, so let's take a look at some of the examples below. It says simplify each expression, and it's asking us what do we do with the bases that have no exponents on them. Remember, if there is no exponent, okay, it indicates an exponent of 1. Okay, so we'll remember that as we move along. In example A, we check to make sure we have the same base, so our base is 3 in each one of them. We keep that the same, and then we add our exponents. We get a 3 to the 5th power, and if we take our calculator, okay, we're plugging that in, use the little caret button, we get 243. Now, that's a little bit large for us to memorize, but if you've got your calculator, you can always evaluate something that large. Each time you do this, you want to check that the bases are the same before you add your exponents. So in part B, it's a little bit different. We have 3 pieces. 2 of them have a base of A, and 1 of them has a base of B. We also have an A that has no exponent. So remember, that means there's really an exponent of 1, so we can add that in there. And we're going to combine the exponents just with the bases of A. So we keep the base of A and we add our exponents. 5 plus 1 is 6. And then our B stays exactly the same. We can't combine those two exponents because their bases are different. In part C, our bases are the same. We have a 2 for each base. We combine our exponents by adding. 2 plus 3 is 5. And 2 to the 5th power is 32. When we have numbers for our bases, we're able to evaluate. For example, in part A, we got that 243. In part C, we got that 32. But in part B, when we didn't know what A and B were, we had to use, we couldn't simplify completely. We had to leave them in the form of the exponent. Moving along, part D, got M is our base for both, and we're going to add our exponents. So 5 plus 7 gives us a power of 12. If we look at part E has 2 values that have a base of x and 2 values that have a base of y. So we're going to be able to combine the x's and combine the y's. So x is one of my bases. I'm going to add my exponents. My 2 plus my 3 is 5. My y is my other base. Add my exponents. The first y doesn't have an exponent, which remember means it's an exponent of 1. If we add our 1 plus our 4, we get 5. In part F, we've got a negative exponent, but it doesn't change what we're going to do. As long as the bases are same, we can add our exponents. So we get x is our base, and we're taking our negative 3 plus 6. Negative 3 plus 6 is a positive 3. So don't let those negatives throw you off. You just add them the way that you would any other. Okay, so as long as the bases are the same, you keep the base, you add the exponents. All right, let's move down here and take a look at some simplifying. Okay, what happens when we have leading coefficients on our bases? Leading coefficients are the numbers in front of our x's or our variables. What we can do is take the numbers and we can work with those first. So let's zoom in here a little bit. If we want, we can rewrite this. What we're really doing is we're going to take negative 2 times 3. We're going to deal with that first, and then we're going to deal with our x's. So let's go ahead and multiply our numbers together. We've got negative 2 times 3 is a negative 6. And our bases for our x's are the same, so we leave that x and then add our exponents. Negative 2 plus 5 is 3. And that's as simplified as we can get. Our next one, okay, same thing. And you don't have to keep rewriting it out. You can if it helps make sense of what you'd need to do. But you can go ahead and take your 6 and your 3 and multiply. 6 times 3 is 18. Okay, our bases are a's, so a, and then let's add our exponents. The second a doesn't have an exponent, so that indicates an exponent of 1. Add our 3 plus our 1, and we get an exponent of 4. Part C, take our numbers. Negative 5 times negative 3 is a negative 15. Oh, no, it's not. It's a positive 15 because a negative times a negative is a positive. We have a base of c for each of our exponents, and then we add our exponents. 2 plus 7 is 9. All right, in our next one, okay, we have the negative exponents, but don't let that throw you off. Start with your numbers again. Negative 3 times 4 is a negative 12, because it's a negative times a positive, so we get a negative. X times x gives us, x to the negative second times x to the negative ninth. Our bases are the same, so we keep our x, and we add our exponents. So negative 2 plus a negative 9, we get even further negative, so we get a negative 11. We want to simplify completely, which means that we should never have a negative exponent. If you recall from 7.1, negative exponents mean that you're going to move to the opposite side of the fraction bar in order to make that value of your exponent positive. So we leave our negative 12, but our x to the 11th moves to the bottom and becomes positive. And this would be completely simplified. So in order to be completely simplified, you should never have a negative exponent. In part E, okay, we're going to do the same thing, except now we have several parts. So start with your numbers. We've got 4 and 2. So if we multiply those, we get 8. 4 times 2 is 8. We have 3 bases. We have an x. Okay, we can add our exponents. 2 plus 4 is 6. We can add the exponents for our y's. 5 plus 2 is 7. And we can add the exponents for our m's. 3 plus negative 7 is a negative 4. Now remember, we don't want negative exponents if we're going to be completely simplified. And we leave everything that has a positive exponent where it is. So my 8 stays, my x to the 6th stays, my y to the 7th stays, but my m to the 4th has to move to the bottom, which makes that exponent positive. So we've got our value completely simplified. So it says over here on the right, what do we do when the result has a negative exponent in it? Remember to simplify by moving that exponent to the opposite side of the fraction bar and changing the sign to a positive for the exponent itself. This completes notes for 7.2. You now want to work on 7.2 practice. Thank you.